And hello viewers, you are watching Tech Trace. Today I am going to show a tutorial about how to design a bearing block. You know what is about a bearing block? Yeah, I will tell you. First of all, you have to prepare the worksheet in the Solidworks tool. Just click new. In that part, select the part to draw a 3D diagram component. Click OK. Yeah, here we have to do some extruded command I'm going to use. So click extruded boss and boss button. Select the plane which you have to draw or extruded with a plane or a region. So I'm going to choose a front plane where the bearing block will come. So just use a rectangle command. Click the rectangle button and do your rectangular part. Now click a smart dimension. Just give it as a 200. Here just to give it as 25. So that rectangle will keep ready. Why I am choose this dimension 225? This will be the basement of the bearing block where the load will come from that shaft which is rotated between the bearing of the bearing block. Here the 25 thick will have to withstand that compressive load which is come from that higher RPM rotating shaft. So this bearing block will not only bear the shaft not only easily rotate the shaft, or to not only to reduce the friction between the shaft and the mating parts. It should capable to withstand carrying the load with efficiently. So that only I have selected 25 mm thick. This will involve some calculations, like in the point load between the midpoint of this rectangle. By using the point load, and the reaction will be the UDL, yeah, uniformly distributed load. You have to calculate the uniformly distributed load, which means give that stress using that shear force diagram and the bending moment diagram. You can select that 25 mm thick. If I just choose the topic, that will be more discussable. You can ask me or comment me in that comment box in here. I will choose. So next you have to select a circle. From there I have to select and draw a circle which meets at the center point. So now click smart dimension. I have to select it as a 40. Now so bearing block, that bearing shaft will be the 30, means that outer race diameter of the bearing will be 60 mm diameter. So 60 mm diameter, the bearing block outer flange diameter will should definitely the thickness what we are choosing. So 25 mm plus 60, it will be 85 mm. So the radius will be the half of the diameter, 85 divided by 2, 27 point 7.5. Yes, it's came 85, 47.5. Yeah, I got it. Yeah, okay, then this should be 95. I think so. It should it should be 37.5. I think I am poor in mathematics. Now finally I got it. That's 42.5. Sorry for the viewers. 85. So this should be 60. Okay, just I want to fillet this object here. This radius will be same 25. This one entries to fillet this thing and this thing. Will not come for fillet, I think so. Yeah, so I have to choose an arc command. Yes, 3-point arc. 3-point arc will not give sufficient dimension, but in here 3-point arc will more sufficient whenever comparing. Actually, I have to draw a reference line that would come under this. Yeah, just click smart dimension, make it as 25. Now 25. Yes, now I can do 3-point arc. Click in here, click in here, click in here. Okay, zoom it. Okay, click escape, delete the entries you doesn't want. Yeah, I done it. Delete it. Yes, it's gone. So I have to mirror it, mirror the entries, select the entries to mirror. Okay, mirror about this center line. Now I have to draw a reference line that could easily do with the mirror. Yeah, now follow mirror, select the entities, yeah, then click the about line, click OK. Yeah, you done. Delete. Yes, you delete it. So now I want to trim the object, trim the entities. Yes, trim, click trim, select the object here, here, and here. Power trim. Here list of trim here, trim options here. I think corner trim I have to do. Yes. Even power trim is I think closely can cut. Yeah. Yeah, that's it. That's it, viewers. Here zoom it, some extension is here. Yeah, that's it. Now that's it, viewers. That's it. Click OK, then fillet that radius should be 2, no, 3 is sufficient. Likewise, do. Yeah, I done. Click OK, finished, and click exit sketch. You can now turn into a 3D object. Yeah, you got it. That actually just mention the length what should be. Actually I want 50 mm length of this bearing block. Yeah, got it. Click OK. Now I got the bearing block. Here you can see. Now I want to fix a bolt. Yeah, bolt that should be fixed in this flange to maintain this bearing block not to come out. So use this extruded cut command. Yeah, select the plane, extrude circle, select that point what should be here, so it should be almost here. We can adjust anywhere we want. Yeah, we want. just click here, and here the dimension should be created from the selected items. So click the line command, draw this thing, then do small dimension to this one. Normally I am going to fix a 10 mm bolt here. So 10 mm bolt means there should be the hole 11 mm hole to tight into the flange, which means a base plate there. Base plate will be the tapped hole there. 10 mm 10 mm metric thread tap hole is there. So 11 should be the diameter, which means the bolt head should be for 10 mm means there should be 18 mm the hole. So the tear area we have to calculate, so that will be 4 to 5 mm for the 10 mm hole. So 18 divided by 2, 9 plus 4, that should be 13. So plus 2 mm we have to do clearance, so 15 should be sufficient. Just delete this line, this is not we want. You see the smart dimension here. This one select main. This actually my system is around 2 GB RAM. This should not think well capable to do this one. Anyway, this circle dimension I have to choose it as 11 mm. 11. Okay, 11. Okay. I think mirror the centuries. For mirroring it should not possible here, so I have to move to top plane. Yeah, top plane is here. I have to draw a line which mention yeah, now I have to do mirroring easily. Mirror this arc about the line here. Yes, click OK. Click exit sketch. Move to 3D angle. This should be through all. So select the contours here. I have to select the contour, this thing and this thing. Yes, click OK. Now you produce the holes. Yeah, absolutely the holes. Here you can see. Yeah, the hole is cam. See how it is. This is the face. This face should be a grinded face or a scrapped face. That should perfectly hold it in the place. Where the base plate you can give a groove to fix this bearing block to not to move or in a micron way. Yeah, here you can insert a bearing here which is used as a interference fit, and then you can insert a shaft. You can run your shaft. Yeah, absolutely run your shaft. This you have to export into a drawing sheet to issue into a manufacturing unit. Yeah, this I have to save it as B in BLK. This is just for my reference and short forms to save that. Anyway, it will get saved. Some loading going on. just like that you can do. So now I am going to discuss you how what is the bearing block here. Yeah, this bearing block, 2C3, yeah, bearing block. This bearing block should used to transfer the power from one dead end to the other end, which is more sufficient when it looks with a projected part. Yeah. Okay. Just I want to do a sectional view to view this object very clearly. So just, yeah, this should be the sectional part. Yeah, section A8 is also automatically generated. Now I have to include a isometric object here. I think this should be quite okay. Yeah, okay. So section A is here, which can include the part. So front view can give that enough dimension. So we have to do click a smart dimension. I have to mention what are all here, otherwise this should be inconvenient. This should be 60 dia. Yeah, diameter, no problem. This should be the radius of 52.4. Okay, this arc should be, how much is actually coming? Actually this coming with 34 point. No problem. This thickness 19, which means the total thickness I have to show, right? So select, .25 thick. Okay, now in the top view it is sufficient. Actually that's no problem here. Just mark the PCD center to center distance. That should be 164. Yeah, absolutely 164. Just click this whole dimension. Yeah, that's diameter 11, and just mention this thickness here, that should be 50, and this should be 194. Will not come because it should be 200. Yeah, 200 is came. 200 is came. So in the sectional view, just for a clearance view, here you can see how the object will come. Don't worry, no problem in here. Anyway, now I created the manufacturing part. Okay, thanks for watching, viewers. Click the subscribe below. You can get more and more technical knowledge here. I think the video length is quite big. Even more faster learning, you can go through here what I am saying here, what you want to know. Just skip that timing, you can do it anyway. Just comment below. Here you can get more and more technical knowledge, right? So comment below your doubt, what are all the real technical doubt. I will reply anytime. Thanks for watching, viewers.